All right, so the recording is on. So here's one of your first problems that I would like you to try. And this is one of your typical one factor questions. And if you are watching this recording, you can pause it now and try it. So let's do this together, because this is why we do these practice to prevent these errors. And oh, and I think I know what you did. All right, so remember, when it's a one factor question, we always look for that doctor's order or the prescriber's order or the prescriber's prescription. And that's what we start with our given. So the PCP orders 2,000 milligrams. So I start with 2,000 milligrams. You can put that over 1 or leave it blank. I like to put it over 1. And then it says on hand, meaning what is available to us, may be delivered by the pharmacist or pharmacy, or in the medication drawer that's just been sitting there waiting for you, is 1 gram. And it happens to be a scored tablet that's scored in quarters. So that means that that tablet can be split like that if needed. So, but what is our wanted? What are we wanting to solve for? Well, it's saying, what are you going to administer? Well, if it only comes in tablets, that's what we're going to administer, is a tablet. So I put that over 1. Tablet has to be my numerator. So how do I get rid of milligrams and get tablets? Well, unfortunately, it's available in grams. So you know what we got to do. 1 gram is 1,000 milligrams. Cross off my milligrams. How do I get rid of grams? I go to my problem. There's 1 gram in every tablet. Gets rid of my grams. So now it's just math. So you can do 2,000 times 1 is 2,000, and 1,000 times 1 is 1,000, and 1,000 divided into 2, and my answer is 2 tablets. Don't forget the unit of measure. All right, beautiful. Let's try another one. Anybody have any questions about that? You feeling?
Yes, I got thrown off with a 1/4.
Okay, I can tell you that what we're probably going to do is because the issue was students didn't understand if it was scored, how was it scored? Because it can be scored either in half or in quarters. So you will see a picture of either a quarter or a half. So what this means is you'll be able to, let's say if your answer was, let's say if your answer came out to be 2.25. That means you would give 2 whole tablets and then a quarter of a tablet.
Okay, I'm sorry. You know what I did? I put 1/4 into my problem.
Oh, yeah. So on the exams, you'll see a picture or it'll say it.
Okay.
Okay. Great question, though. Thank you.
Professor,
Yes.
Kana, with the rounding problem. So when it's 2.25, will it be like that? Like the answer, let's say the answer is 2.25.
If it is a scored tablet in quarters like this, yes. If you can break the tablet, if it's scored in quarters, then yes, you can give 2.25. If it's scored in half, you can't give 2.25. You can't give it because this tablet is only broken in half.
So
that's why we, yeah, so you would not be able to split that in half.
Okay.
Professor K, on that note, like that quiz question that was 3.6. Now we're not supposed to round up on these medications. It's supposed to be rounded down. Is that what we do for like uneven answers to tablet questions?
Nope. If it's 3.6, basically you have to say, is the 3.6 closer to what? 3.5?
Right.
Was it a score tablet? I don't remember the quiz question.
Yeah, it was like 3.5, and I didn't want to go to 4, and I didn't want to go to 5.
Right. Well, which is it closer to? It's closer to 3.5 than it is 4.
Okay.
So it'd be 3.5 for sure.
Okay.
Cool.
Thank you.
No problem. All right, let's do another one. So this is just telling you how the tablet is scored. That means the tablet, if you looked at it, oops. You know I can't draw. Looks like that. Very good. So yeah, these aren't trick questions. I mean, you're going to have pills that are able to be scored. That's just the way it is. They're going to come up and they're going to be able to be split and scored because not every patient's going to get the same strength. So the doctor orders. You got to start with the order. So you have to look at it. You have to read your questions. All right. He orders 360 milligrams. Beautiful. What is my wanted? What am I going to give? What am I administering it? Well, it only comes in tablets, so I have to give a tablet. So I put that over 1 because I need it in my numerator. So how do I get rid of milligrams and get the tablets? Well, I go to my problem. And this happens to be a pill that has 180 milligrams in 1 tablet. So I get rid of my milligrams and now I have my tablets. That's it. I'm all done. So 360 times 1 is 360. And 180 times 1 is 180. And when I divide 180 into 360, it's 2. It's 2 tablets, not 2 question marks, not 2 turtles, 2 tablets. I got to mess with you now, Faith. I'm sorry. I'm going in hard. All right. So just because it's scored doesn't mean you need to score it. Your answer may come out to a whole number automatically. Okay. Let's try another one. So let's do this one together. So I'm always looking for that order. So it says on hand 880 milligram scored tablets. The tablets happen to be scored in half with a perforation. It means there's just a perforation on that pill, so it's easily snapped in half. The primary care provider orders 2,200 milligrams. So there's my starting point. Okay. So what am I administering? Well, it only comes in tablets, so that's what I'm given. And I do the same steps over and over and over, and I really encourage you to do it, even if it's annoying. All right, so how do I get rid of milligrams and get to tablets? Well, I go to my problem. The tablets are available in 880 milligrams in every tablet. So cross off my milligrams, and I have tablets left. So I can actually cross off my zeros if I want to, but that was not intentional. So 2,200 times 1 is 2,200, and 880 times 1 is 880. And when I divide 880 into 2,200, it will give me 2.5 tablets. All right, you can write tabs, you can write tablets, but it gives you 2.5. And because we could split it in half, 2.5 is appropriate. So yes, I know the half is distracting, but this is just so you can know how you can break it break it up, okay? All
So when
right.
it says like half tabs or like 1/4, it's just 1 tab.
Yeah, when if it says it's the scored tab on the exam, you're going to see a picture. All right, you'll see a picture of a pill, and it'll either have a perforation like this, or it'll have perforations like that. Whichever way, if it's this one, it means you can break it in half. If it's this one, it means you can break it in quarters. So
Okay.
I added this here just so you knew when I said score tablets, what type of score tablet it was. All right. You don't use that in your problem. It's just letting you know it's a half score tablet. You can split it in half evenly. All right, here's another type of problem you should be familiar with in preparation. So I'll give you a minute to do this one. All right. So, Latoya, with your question mark, what's the question mark about? Did you round it and you shouldn't have rounded it?
No. It's a mistake. I'm sorry.
Okay, that's okay. I just want to help you if there wasn't.
Sure.
You knew, no problem. All right, so same steps. It's still a 1 factor. The doctor orders 150 milligrams because it says prescribed. That means ordered. So I'm starting with 150 milligrams. And it says administer. So what am I going to give that patient? What am I going to administer to that patient? Well, it's only available in liquid. So that's what I'm administering. And I put milliliters in my numerator. So same steps. How do I get rid of milligrams and get to milliliters? Well, I look to my problem. And it's telling me there's a medication bottle and it's labeled with 125 milligrams per every 1 ml. I cross off my milligrams, that leaves me my milliliters, and that is it. 150 times 1 is 150, 125 times 1 is 125. And when I do the math, it will give me a beautiful 1.2 milliliters. Lovely. All right. I'll have you do this one as well, just to get that out of the way and out of your system, okay? I love it. All right, so we're looking for that given, that order, and here's the order. What's prescribed? 0.44 milligrams. What are we going to give the patient? Well, we're going to give how it's available to us, and that's in milliliters. So I need milliliters in my numerator position. No problem. I go to my actual question, and 0.355 milligrams is what's available in each 2 milliliters of solution, according to that medication bottle. So I'm going to use this for my problem. So 0.44 times 2 is 0.88, and 0.355 times 1 is 0.355. When I divide, I get 2.478. So my rounding rules, 1 to 10, I round to the tenths. I look to the number to the right, and if it's 5 and up, I round up. So my answer is 2.5 milliliters, and that's what I will either draw up in a syringe or pour into a cup and administer it to my patient. Beautiful. So here is a 2-factor. So I want you to try this one. All right, so this is your classic 2-factor. So it's saying the medication is ordered to be administered 0.7 milligrams per kilogram. It's going to be given intravenously every 8 hours. All right, so I always start with my given, my order, 0.7 milligrams, and we set up our 2-factor as such. So we have the strength and the weight on the bottom. So this question is telling you what your wanted is. How many milliliters will you give? Well, that was easy. So I know I'm going to give milliliters. Need that on my numerator. So now it's just a process of eliminating. Now I am somebody who loves to cross off what I used. All right, just to help keep my focus. So if I wanted to get rid of the kilogram, I look to my problem, and I do have a patient's weight, and it is in kilograms. So I'm going to put it up here, 50 kilograms, and put that over 1. That allows me to cross off my kilograms. Beautiful. So now I got to get rid of milligrams and somehow get to milliliters. When I look at my problem, the only thing available is in micrograms. So you know what I got to do? 1 milligram is 1,000 micrograms. Go to my vault of conversions. So now I have micrograms, and I can use my problem. 2,000 micrograms in 1 milliliter. And make sure you're really being methodical and checking your transcription, because a lot of you guys make errors when you write a number wrong, or you add a 0, leave off a 0. You know who you are if you've done it, but it's not worth the error. Just try to stay focused and don't let any squirrels or shiny lights distract you like they do me. So now I can do the long math, or I can cross off my zeros, whatever way you're comfortable with doing it. You can cross off zeros, 1, 2, 3, 1, 2, 3. Just be careful. So if you did that, it would be 2 over 50. Oh, I gotta get my calculator. 50 times 0.7. That would be 35, and 35 divided by 2 will give me 17.5. In my rounding rules, anything greater than 10, I round to the whole number. So 17.5 is definitely greater than 10. 5 and up, I round up. So my answer is 18 milliliters. Beautiful. Good.
Professor, 18. Like where I got confused is here last time. What I did, I went in and the 17 point again time 3 because of I'm always confused with this, like 8 hours, every 8 hours. So I went in the time by 3, and it's longer.
So what would this question say if it wanted to know if you, this question didn't ask you per dose. It didn't say, what are you going to give for the 7 a.m. dose or the 12 noon dose or the 7 p.m. Because if it was every 8 hours, I would ask you how many milliliters would you give for the 7 a.m. dose or the 8, whatever dose it was. This question doesn't say that. So that's why you have to read your questions, okay? Didn't ask you per dose. It asked you how many milliliters would you give. And actually, if you, I don't want to confuse do you practice clinically? Do you work?
Don't confuse them. Don't worry.
No, okay, because I know why that's why I'm asking if you practice. All right. So yeah. So unless it says what will you give for the 7 a.m. dose or a specific dose, then you do not do that.
That's what I was gonna ask too, Professor K. Like,
Right.
what is a trick to, like, when your mind sees those numbers, it doesn't make you want to start this whole computation that you don't even need?
Yeah. I recommend the shock collar, but apparently that's illegal. Yeah, so let's look at this question. The doctor ordered a medication to be administered 0.7 milligrams per kilogram. You're going to give that IV every 8 hours. So he wants you to give 0.7 milligrams per kilogram. So let's think this through. How many kilograms did the patient weigh? 50, right? Okay. So really, he wants 0.7 milligrams for every kilogram. So 0.7 times 50 would be 35 milligrams, right? But they're not asking you what's the total milligrams. They're asking you, what are you going to actually give in milliliters, all right? They're just saying they're going to get 35 milligrams every 8 hours. You have to figure out how many milliliters that is. So you're always starting with your 2-factor. And you're always, if you know where to start and you know where you're going, the other information is you will use it only as needed. You see that we use this, and this. There was no other options in the question. So what other option would you, let me ask you, what confused you in this question?
Every 8 hours, I don't know, it just was making me think, are they asking per dose? If they're asking per, and though I saw it like, okay, cool, every 8 hours, great to know. But when I first looked at it, I was like,
right. So you said it, you just said it. You thought, and then you overthought, and it's okay. This is what everybody does. You originally saw it every 8 hours, but you were solving it and you thought, wait, no, every 8 hours. So now you're overthinking it, even though you've used everything in the problem. If you look at this equation, where would you put every 8 hours?
that's what I thought. I was like, oh, there's nowhere, it's not
Right.
going to.
Right.
So that would be the same if that, I'm sorry, I didn't mean to cut you
Yeah, no,
off.
go ahead.
That
You're
would be
helping
the
people.
same even if that Q8H was TID, QID, it still wouldn't have significance because everything else is there, right?
Unless
Or am
I asked you for a specific time, and I'm going to show you right now.
Okay, that helps me, because if it doesn't say, if it said whatever there, it's not really significant. It said, not unless it said, like, what will you give at the 7 a.m. dose or something like that?
So here
Or
it is,
what
right?
would you give daily?
Take a look at this question. So now I want you to solve this one. All right, so you see the difference with this one. This one is asking you
Yes.
calculate the dose you will give at 9 a.m. All right,
Mhm.
so it's a 3-factor because the order has 3 elements. It says a med is prescribed. 30 milligrams, kilogram, and then we add the day. All right.
Mhm.
Now it's saying in 3 divided doses. So how many times a day is that?
3.
All right. So every day, there's 3 doses. This gets rid of day.
Oh, you know what? It was something simple. If I would have
Yes,
looked
it
at
always is, right?
my setup, I would have saw that I had day in the wrong place.
Oh, okay.
I put day at the bottom by mistake, but somehow I crossed it off, and I don't know how.
Okay, so every day that patient's getting 3 doses. So it gets rid of the word day and it gives me dose because they need to know what you're going to give at the 9 a.m. dose. So what are you going to give at the 9 a.m. dose? So now I have the word dose. So now I can continue to eliminate. Now, how do I get rid of kilograms? Because I don't need kilograms. I used in my problem 66 kilograms over 1. That gets rid of kilograms. So now I have to get rid of milligrams and find milliliters. Well, I go to my problem. I've used this. I've used this. I know the time. All right. I've used this and I have this I haven't used. And it's in grams. I need to change milligrams in grams. 1 gram is 1,000 milligrams. That gets rid of my milligrams. Now, how do I get rid of grams? 0.5 grams per 1 ml. And that's the entire setup because then I'm left with only milliliter and dose. And now it's just math. So it'll be 1980
80.
over 1500, and that will give me 1.32. And 1 to 10, I round to the tenths. 2 is not 5 and up, so it is 1.3 milliliters per dose.
Is it 1950 or 1980?
1980.
Okay.
Sorry. 80. So did you find your error in the setup?
Yes.
Okay.
Mhm.
All right. So now I'm going to pop back to this one. All right. You guys are doing really good. It's just getting out of your own head when you're doing these problems. It's always the biggest problem. All right. So we're looking for that given that order. And here it is. The MD ordered a med to be administered 8 milligrams per kilogram. It's a 2-factor, 8 milligrams per kilogram. All right. And it happens to be give intravenous, and they're going to give it every 12 hours. That's good to know, like you all said before. It's good to know because as the nurse, you need to know how many times you're going to give it in a shift if you're responsible for that. But these are how doctor's orders are written. And it's telling you that what's available, maybe delivered from the pharmacy, is 1,200 micrograms per 2 mLs, and the patient weighs 45 kilograms. And it tells you what the wanted is. How many milliliters will you give? So I put my milliliters. So I know where I'm starting and I know where I'm going. It's a process of elimination. Get rid of kilograms first because it's easiest. 45 kilograms is the weight over 1. I do it diagonally, cross it off. I've already used this, 0.8. All right, how do I get rid of milligrams? Well, it's in micrograms, so I know I need a conversion. 1 milligram is 1,000 micrograms. Gets rid of my milligrams. How do I get rid of micrograms? I go to my problem. There's 1,200 micrograms in 2 milliliters. Beautiful. I've used that, and now I'm left with milliliters. I always look over my problem, make sure everything I don't want is crossed off, and then if I have what I need, now it's just math. So you can do a long math, cross off, whatever you want. I'll cross off a couple zeros, but make sure you're careful when you do it. All right. So then I do 0.8 times 45 times 1,000 times 2, 720, and then 12 times 1 is 12. And when I do that math, I'm going to give that patient 60 milliliters. I'm going to put it in a medicine cup and have them drink it. Cool. All right. So right away, you see the difference. Let's do it. Let's do it. All right. So it's a 3-factor, 20 milligrams per kilogram per day. Beautiful. What are you going to give at 6? So I need to use my divided doses. So I'm starting there. There are how many doses in a day? Every day, 4 doses. Get rid of day. Beautiful. How do I get rid of kilograms? I use what's in my problem. 41 kilograms. Boom. Love it. Get rid of my kilograms. All right. How do I get rid of milligrams? And I have to give milliliters per dose. So I already got my dose. So how do I get milligrams? Get rid of milligrams to get to milliliters. Well, I use what's in my problem, but unfortunately it's in grams. So 1 gram is 1,000 milligrams. And That gets rid of my milligrams, and there's 0.25 grams per 1 ml. Gets rid of my grams. I have milliliters. Now I look over my problem. All right, everything is crossed off that I don't need, and I have exactly what I need. Beautiful. Now it's just math. So if you do the long math, short math, 820, oh, I'm sorry, 820 over 1,000. I might have crossed off some zeros here. Trying to think here. 41 times 2. Let me just check my math. 41 times 2 is 82. All right. 41 times 2 is 82. Sorry. 82. And 4 times 100 times 0.25 is 100. And I encourage you to cross off if you have to, because your calculators don't do it for you. So it'll give you 0.082 milliliters. 0.82 milliliters per dose. Now on the exam, I prefer you write everything out, but you definitely have to remember the 0 before the decimal, so we don't mistake 0.82 for 82, and if we're giving it to a toddler or a child, okay? So 0 before the decimal, and it's less than 1, so we go to the hundredths. 0.82 milliliters per dose. Let me see you solve this equation. So remember, you look for that word. If it says IV pump in your problem and it's saying what is the infusion rate, the drop rate, the flow rate, you are always solving milliliters an hour. Okay, so now the next step I do is I look for that volume over time. It says 1 liter, that's a volume. My time is 10 hours. Now I need milliliters an hour. So what is 1 liter? 1,000 milliliters. Right, 1,000 milliliters. And the doctor wants 1,000 milliliters run over 10 hours. Oh, and do you see what you did wrong? You got it now, I'm sure. So when I look at my problem, I have milliliters and I have hour. That's it. Now I just divide. 10 into 1,000 is 100 milliliters an hour. So I'm going to program that into my infusion pump. It's a machine, and I'm going to hit start, and it's going to give that patient 100 milliliters every hour. Okay. Okay, I want you to try this one now. All right, what's got everybody stumped? Let's figure this out together, okay? We got to look at our problem. The first thing I'm looking for in my question is the word pump. Now, this question, I do not see the word pump. No pump. But what do I see is a drop factor. No pump and a positive drop factor. So what am I solving for? What is my wanted? Drops
per minute.
Always drops per minute. There's no IV pump. We're doing gravity. No pump, positive drop factor. It's asking for a flow rate or a drop rate or an infusion rate. It's drops per minute. There's no pump. So I know what my wanted is. So I need drops in my numerator, minutes in my denominator. And then I start with my volume over time. 600 milliliters over 5 hours. Okay. How do I get hours to minutes? 1 hour is 60 minutes. That crosses out my hours and it gives me minutes in my denominator. Beautiful. Now I have milliliters and I need to get to drops. So I've used this. Is there anything in my problem I can use? Well, there sure is. There's 10 drops per milliliter. That's my drop factor. So I'm going to put 10 drops per 1 milliliter. That gets rid of my milliliter and it leaves me with drops. I look at my problem. Everything I don't want is crossed off, but drops is in the numerator and minutes is in my denominator. I'm ready to solve. All right, so now it's just math. So 600 times 1 times 10 will give me 6,000. And 5 times 60 will give me 300. And when I divide 300 into 6,000, it will give me 20 drops per minute. Beautiful. Simone, did you find your mistake?
Yeah, I forgot to convert the hour into minutes.
There it is, every time. So if you always write that wanted in the way you need it, it'll hopefully help you stay focused on what you're trying to get to. All right. So let's try another one. Hold on. Okay, I want you to try this one. Again, not a trick. This is how orders are written. These are how IV fluids are written. So 2 liters of normal saline over 12 hours. So during your 12-hour shift, you're going to give that patient 2 liters of saline. But how fast are you going to plug it into the pump? So what do? I look at my question. The first thing I look for, does it say the word pump? And it sure does. So positive pump. That means I never use a drop factor. This one doesn't have one in it, so I don't have to worry about it. So if it's a pump, I'm solving milliliters an hour. Beautiful. So then I look for my volume over time. It's a 2 factor. Infuse 2 liters over 12 hours, 2 factors. Volume 2 liters. I don't need to convert it using dimensional analysis. By now I should know 2 liters is 2,000 milliliters. But you could do the long conversion if you needed to, over 12 hours. And when I do that, I already have my milliliters and I already have my hours. Beautiful. Now it's just math. But this math will give me 166.66. Now, I still follow the rounding rules, okay? Because in the pump, I can use a decimal, but I have to still follow the rounding rules. Anything over 10, I round to the whole number. So this one would be 167 milliliters an hour. And I would plug that into my computer, my IV pump, 167, and I would hit enter or start. And then it would start the infusion. All right, beautiful. When you see this on the screen, it says a patient is to receive 800 milliliters over 6 hours. The drop factor is 20 drops a milliliter. What is the drop rate? What's missing from this question? There's no pump being used, right?
Yeah.
And they give me a drop factor. So what am I solving for? What's my wanted?
GT drops per ml. What is it? Oh, per minute.
Drops
Right?
per minute.
Yeah,
Right.
drops per minute.
Exactly. Because I don't have an IV pump. If I had a pump, then it would be milliliters an hour, but I don't have a pump. It's
So
drops.
it's always gonna be GTTMN. Okay, by minutes, got it.
So now solve this one for me. And so, yeah, there's no pump. I'm gonna count drops. I'm looking for that volume over time order. It's 800 milliliters in 6 hours. All right, but I need minutes in my new denominator. So 1 hour is 60 minutes. Gets rid of my hours. Beautiful. I have my minutes. I need to get drops and I have milliliters. Well, I'm going to use my drop factor. 20 drops per 1 ml. That gets rid of my milliliters and I have my drops. I'm done. I just got to do math. So when I do the math, it's 1600 over 36. Did I cross off? Oh, I might have crossed off maybe. I crossed off a 0. Sorry. I do this to you guys all the time. 36 divided into 1600 is 44.44. I cannot split a drop unless I'm Latoya. All right. But you can't split drops.
Sorry.
No, it's good. You can't split drops. I want you to think about that. When that's dropping in the chamber, we can't split that drop. I want you to get that visual. All right. So I have to round to a whole number. So 4 is not 5 and up. So I'm not rounding up. So it's 44 drops a minute. Beautiful. All right. Now, here's another problem you should be familiar with in preparation for your exams. Actually, you have several coming up, right? You're a unit 2 and final, but your unit 2 is coming up. So this is a good one to be familiar with. All right. So this is, you know how weird I am about this stuff. I have to keep doing it the same way. So I'm reading this problem. A med has to be administered 12 micrograms per kilogram per minute. That's a 3-factor. The IV has a label on it. It tells me how much of a med, 125 milligrams and 100 milliliters. It gives me a patient weight, and it's telling me there's a drop factor of 20. And it ends with saying, calculate the infusion rate for the IV pump for this patient. And this is why I do what I do before for the simpler ones. So this question says, it has the word IV pump. So what does that mean about the drop factor?
Milliliters per hour. Oh,
I don't need the drop factor, and I'm solving, it's asking me infusion rate. I'm solving for milliliters an hour. Okay. So I cross off what I've used. It's a 3-factor. I start my 3 factors the same way I always do. 12 micrograms per kilogram per minute. So now I need hour in my denominator, and I have minute. How do I get rid of minute and get to hour? The same way I have been. There's 60 minutes in 1 hour. I have hour. Now I have to get rid of kilogram, but the patient's weight is in pounds. 1 kilogram is 2.2 pounds. Crosses off my kilograms. Well, now I got to get rid of pounds. Now I can use my patient's weight, 123 pounds. Put that over 1. So I've used that. And now I've gotten rid of pounds. Fantastic. But now I have micrograms and I need milliliters. The only thing left in my problem I haven't used is the concentration, but it's in milligrams. So what do? Convert. 1 milligram is 1,000 micrograms. That gets rid of my micrograms. Now, how do I get rid of milligrams? You see how it's this process of eliminating the unwanted. Well, now I can use what's in my problem. The only thing left in my problem. I can use the 125 milligrams in 100 milliliters. That gets rid of milligrams, and look at that. Now I have milliliters. I look at my entire problem. Everything that I don't need is crossed off. I didn't get fooled by drop factor because I found the word pump before I started everything. And that's why I always say, start with your given and identify your wanted, and then it's just a path to get there. So now this is just math. It's disgusting math, but it's still just math, okay? So you can cross off zeros and to get to your destination. So when you do cross off zeros, you can cross them off like this. When you do the math, it'll be something grotesque, but I got 8856 because I eliminated zeros over 275. And when I divide that, it gives me 32.20. And now I'm using a pump. I can use decimals, but I have to follow the rounding rules. Anything greater than 10, I round to the whole number. 32.2, 2 is not 5 and up, so my answer is 32 milliliters an hour. And congratulations, you are now calculating critical care medications for your patient. All right, so this is a classic 3-factor to set up in an infusion pump. All right, so let's do another. Let me find them. Okay, do this problem.
too many numbers.
There is. There's always too many numbers. All right, so the answer is 169 milliliters an hour. So I'm going to still follow this whole method that I use because I believe it worked for me. So I'm going to use it and hopefully you'll use it. I'm looking at my question. A med is to be administered 32 micrograms per kilogram per minute. I got a 3-factor question. I got a concentration. I got a weight in pounds. I got a drop factor, and they need to know the rate of a pump. A pump. I don't need my drop factor. I'm getting rid of that. And a pump. Positive pump. Oh, where did my screen go? Oh my goodness. I'm writing and nobody's there.
We're
Sorry.
seeing your name, not the screen.
I don't know. We gotta find it again. My goodness, I was writing like crazy. All right, hold on, stand by. Is it the internet?
I figured it out.
You did? All right, hold on. All right, so like I was saying, I have a pump and I'm not going to use my drop factor because I have a pump. I don't need the drop factor. So I'm solving for milliliters an hour because it's saying infusion rate. What am I going to run this IV fluid at? So I know where I'm going. Milliliter in my numerator, hour in my denominator. Beautiful. All right, I'm starting with my 3-factor, 32 micrograms per kilogram per minute. Done. So what do I want to get rid of first? It doesn't matter. I can do weight this time. Let's get rid of kilogram. How do I get rid of kilogram? I use the patient's weight, but his is in pounds. So I use a conversion. 1 kilogram is 2.2 pounds. Gets rid of kilogram. Now I can get rid of pounds. 159 pounds over 1 gets rid of pounds. Crossing it off. So there's only one thing left in my problem to use. So 205 milligrams in 250 milliliters, but I have micrograms. So another conversion. 1 milligram is 1,000 micrograms. And now I can get rid of milligrams using my problem. 205 milligrams in 250 milliliters. Boom, boom, boom. And now I have milliliters, and now I have to get minutes to hours. 60 minute is 1 hour. And I'm done. It's gross. It's long, but I can solve now for math because I'm going to look this over. I definitely have it set up beautifully. So when I do all the long math, literally long math, 763,200 over 4510 will give me 169.22. Anything over 10, I round to the whole number. So it's going to be 169 milliliters an hour is what I'm going to set that pump on. Oh, yeah. Cool. So if you had me in 118 and we had a cardiac lecture, you should be familiar with heparin. So go ahead and solve this. All right, so this is heparin. I still follow the same process. I still got to know, even though it's telling me what I'm going to give or what I want, I still follow the same process. So when I look at this, I say the patient's got to get 2,000 units per hour. All right, that's what's ordered. All right, that's my given. Pharmacy has 20,000 units in a bag of normal saline that's got 250 milliliters. And it's telling me how many milliliters an hour because it's a pump. So this one was a gift. It tells you how many milliliters an hour will you set on that pump. All right, so now I'm going to look at the order. 2,000 units per hour. So this is not a volume, but it's a strength over time. 2,000 units per hour, or a unit of measure over time. All right. So now I've used 2,000 units per hour. That's my given. I start with my order, and that's a 2-factor order. That's another way to think about it. All right. So now that I've got that, so I already have hour. How do I get rid of units and get to milliliter? I'm going to use what's in my problem. So there's 20,000 units in 250 milliliters of normal saline. Cross off my units. Beautiful. So now 1, 2, 3, 4. 1, 2, 3, 4. 25 times 2. I don't even know. I'm going to do the math. 25 times 2 is 50. And then over 2 divided by 2. And that will give me 25 milliliters an hour. Beautiful. So that's one you've got to be familiar with how to do. All right. And now I have another one. Well, I'm going to just test you on this one. I want you to try this one, and then we have one more type. So everything you've been exposed to is what you should expect. All right. So just to respect time, let's look at this question. How many, the doctor ordered, and it's called the safe dose because they're telling you the safe maximum limit this patient should get. All right, the safe dose of a drug is 0.08 milligrams per kilogram per day. That's a 3-factor. 0.08 milligrams per kilogram per day. So what is the correct daily dose for a patient who weighs 106 pounds? So I've already used this. There's a weight. There's no other information in this question, right? So what is the correct daily dose? So I'm solving for something per day, and it only comes in one dose, and that's milligrams. There's no other information. All right, if you think about it that way. So let's start eliminating what we don't need. Well, I have milligram. Beautiful. I have day. Beautiful. I just have to get rid of kilogram. And the only thing I have is in pounds. So 1 kilogram is 2.2 pounds. And the patient weighs 106 pounds. And literally that is it. Now it's just math. So this will be 8.48 and this will be 2.2. And when I divide into that, it gives me 3.8545. 1 to 10, I round to the tenths. Look to the number to the right, 5 and up, I round up. The answer is 3.9 milligrams a day. Beautiful. Love it. But I want you to do this one for a reason. All right, so I did this not to torture you, but to review that rounding, okay? So, right, Rosemary, I'll show you what's going on. So it's a 3-factor, 0.02 milligrams per kilogram per day. What is the correct daily dose? It's only available in milligrams per day. So I need the word day and I got it. I need milligrams and I got it. So I have to get rid of kilogram. The patient weighs in pounds, so 1 kilogram is 2.2 pounds, and the patient weighs 10 pounds. It's a baby over 1. So I get rid of kilograms and pounds. So when I do this math, it'll give me 0.2 and 2.2. Now, when I divide 2.2 into 0.2, we're going to get 0.090909. So the rounding rules are less than 1, we round to the hundredths. But remember, it has to be a significant number. 0 is not a significant number, and the hundredths is 2 places, okay? So it would be the next number over. And it would be a significant number because 9 rounded up is 1. So the answer is actually 0.091 milligrams a day. Okay? So I just wanted to show you that, especially if you're going to be working in NICU, any kind of neonatal intensive care scenario, you go to the significant numbers for the rounding rules. So remember, less than 1, it's 2 significant numbers to the hundredths. 0 is not a significant number. So you would go 0.091, okay? Now, the final problem you should know how to do. Stand by, hold on. Everybody's favorite, left in the bag. I'll give you a minute to do it. All right, let's do it together. So this is basically saying that at some time an IV was started, and in the whole IV bag was 500 milliliters. All right, and that IV fluid has been running at 12 drops a minute. All right, and it tells you what the drop factor is of the IV tubing. But it's also saying that at 9 a.m., you as the nurse walked into that patient's room, and when you looked at the IV, there was only 150 milliliters left in the bag. And as the nurse, you need to know what time will that 150 milliliters be done infusing, so you know when to bring in a brand new bag of IV fluid so it doesn't go dry. All right, that's the reason we do this, why we calculate this. All right, so where do we start? Well, we always start with what's left in the bag, what you assess, what you saw when you went in the room. This is just telling me this was the original amount. That is long gone. At least 350 milliliters of it is already gone. I am only concerned with what's left in the bag, and that's where I start. So when I walked in the room, there was 150 milliliters left in the bag. Okay. And it's asking me what time, in military time, by the way, will the IV be empty? Will that 150 milliliters be gone and in the patient? All right. So I'm solving for time, which is hours. All right. So I need hour in my numerator. Okay. So let's do this. Let's use our problem. What's in our problem to solve this issue? So I've used 150 milliliters. I don't need the 500 milliliters. I already said that. All right. So if I'm just trying to eliminate, how do I get rid of milliliters? Because I don't need milliliters. I need hours. I go to my problem. In my problem, I have 20 drops per milliliter. And when I use this, it lets me get rid of milliliter. Now I have to get rid of drop. I go to my problem. There are 12 drops every minute. 12 drops per minute. That allows me to get rid of drops. Now, how do I convert minute to hour? I know this one. 1 hour is 60 minutes. It allows me to get rid of minutes and it keeps hour in the numerator. So I look at it, everything that I don't need is crossed off and I have what I need, hour. Beautiful. So I'm ready to solve. This is my first step though. So 150 times 20 is 3,000 and 12 times 60 is 720. And when I do the math, 3,000, 720 divided into 3,000 will give me 4.166666666. It'll keep going. Now I need you to remember this. All right. The number before the decimal represents hours. 4 hours. The number after the decimal represents minutes. You have to keep at least 6. You have to go at least 6 spaces. 1, 2, 3, 4, 5, 6. When you do the calculation, you never round until the very end of your problems for anything in calculations, okay? So I'm going to multiply 0.1666666 times 60. And when I do that, it will give me 9.999. And when I round that for minutes, 9.9 minutes is 10 minutes. So it's going to take this bag, 150 milliliters, 4 hours and 10 minutes, and 4 hours and 10 minutes to run into my patient. But the question's not asking me how long it will take. It's asking me what time it will finish. Well, what time did I walk into that room? 9 a.m. So if I walked in at 9 and 4 hours and 10 minutes later, I go back in, it will be 13:10. I just added. I add 4 hours and 10 minutes to 9. So when I do the math, 9 times 410 is 1310. And that is what I'm writing on the answer line. That is military time. 1310. You're not writing 13.10. That's wrong. You're not writing 13 .10 whatever. You're not writing 4 hours and 10 minutes. That's wrong. It's saying what time. I need to know what time I'm walking into that room with a brand new IV bag. Okay. So now I'm going to have you do one more and then we are done until tomorrow. All right. I'm going to pause it here so you can try. All right, let's do it. Let's do it before my dogs abandon me. Okay, enough. I got a different answer, so let's figure out what is going on. All right, so again, what's going on? So somewhere along the lines, an IV that had 800 milliliters was infusing at 15 drops a minute. The drop factor is 8 drops a milliliter. Beautiful, great information. Okay, but at 10 a.m., Professor K walks in the room to do an assessment, and she notices there's only 350 milliliters left in the bag. What time will the IV finish? So Professor K can go back in with a brand new bag. So I need to start with what's left in the bag, 350 milliliters. Boom. I don't care what they started with. I use my 350. I'm solving for hour. So how do I get rid of milliliters? I look at all my options in my problem. And the only thing with the word with milliliters in it is 8 drops per milliliter. So I'm going to use it. 8 drops per milliliter, and that eliminates milliliter. Now, how do I get rid of drops? Well, I look to my problem. The only thing with drops in it is 15 drops per minute. Gets rid of my drops. Now, how do I get minutes and hour? Well, there's 60 minutes in 1 hour. Beautiful. Now I have hour. I've used every single thing in my problem. There's nothing else that I can use until I'm doing my final step, of course. So now I do my math. So when I do my math, it'll be, let's see, 2,800 over 900. When I divide that into there, I will get 3.1231111. I'll go as far as it'll let me. So what does this represent? I've got 3 hours and 0.111111 times 60 is 6.666. That's minutes, so I'm rounding that to 7. So it's 3 hours, 7 minutes. Okay. So if I have 3 hours and 7 minutes, I write it 3 hours and 7 minutes. And this is where people usually get it wrong. I went in the room at 10 a.m. It's going to finish in 3 hours and 7 minutes. I have to go back in the room at 13:07. Beautiful. Sounds good? No? Hello, is anybody out there?
Yes, I don't know. I have that, and I don't know why I went in.
Yes.
I don't know what I did.
You don't know what you did?
I mean, I got it right. I got the same
Oh,
thing.
all right. You're like, I don't know how I got it right, but
I don't know what I wrote here. 693. What is that?
I don't know.
Professor, I have a quick question.
Sure.
So if I were just to get, let's say 3.2, am I still gonna do 0.2 times 60, or would it just be 3 hours and 2 minutes? If that makes sense.
If you got 3.2 after you did your division?
Yes, instead of like 3.2222. Or like,
Oh, yeah. If you got 3.2, it's everything 3 hours and 0.2 times 60.
okay.
Yeah, everything after the decimal is minutes. So you'd have to do 0.2 times 60, and that would give you 12. So it'd be 3 hours and 12 minutes. So you would write that as 3:12. And then if you walked in at 10, so now that would be done at 13:12. All right. Either way, you're still multiplying that anything after that decimal by 60.
It's gonna be multiplied. Okay, thank you.
Yep, you got it. Well, I hope this helped. Keep your notes. Focus on these type of problems to prepare you for Unit 2. Again, I'm having a class, tomorrow at 10. Who picked that? Oh, okay, me. But you're welcome to join again if you like, and we're going to do the same thing. All right. So
Professor-
thank you. Yes,
Quick question about tomorrow. Is it
Yeah.
gonna be the problems or different ones?
I do have the different ones for tomorrow.
Different, okay, good. All right,
Yeah. Simone, if you want to stay on,
okay.
but everybody else, if you have any other questions, I hope you can come back tomorrow. If not,
Yes. On Kana.
you coming back tomorrow, Connor?
Yes.
Okay, I'll see you at 10.
Thank you, Professor.
You're welcome.
Okay, Professor, have a good afternoon.
You too.